Myself, Rajendra Kumar Singh, Professor of Physics at Banaras Hindu University, Varanasi, India. The topic of my presentation for LEAP workshop is Ionogel electrolytes for rechargeable lithium batteries. The plan of presentation includes brief introduction followed by Ionogel polymer electrolytes obtained by dispersing ionic liquid in polymer or polymer electrolytes. Then some of our results on Ionogels obtained by dispersing ionic liquid or ionic liquid salt solution in porous matrices, followed by a brief summary. Actually, due to limited lifespan of fossil fuels, which are expected to exhaust in a span of about 100 years, there is emphasis on search of alternative energy resources. Energy resources like solar and wind, which have very high capacity, needs energy storage devices like lithium batteries. Although lead acid batteries are well established in the market, but they suffer from the safety issues as well as they are toxic. India being one of the signatories of Paris Agreement, therefore we have to shift slowly to lithium batteries and to other chemistries. One of the consequences of fossil fuels is that emission of about 25% of CO2 and about consumption of 1/4 of fossil fuel by transport sector. Therefore, efficient strategies are to be formulated for coping with the situation. Government of India has targeted a capacity of about 175 gigawatts of solar and wind energy. These intermittent energy resources require efficient storage devices in terms of lithium batteries. But the safety issue is one of the key concerns so far as lithium batteries are concerned. For application of lithium batteries in electric vehicles and hybrid electric vehicles, as well as for energy storage, their discharge capacity needs to be further enhanced along with energy and power density. Although lithium batteries are well established in commercial electronics market, but for their application for high energy and power density applications like in electric and hybrid electric vehicles, one of the key concerns is related to the safety, and energy and power density also needs to be enhanced. Conventional lithium batteries use liquid electrolytes in which lithium salt is dissolved in conventional plasticizers like ethylene carbonate, propylene carbonate. However, these pose safety risk, and therefore recently organic ionic liquids which are non-flammable and have high conductivity are being used in place of conventional organic plasticizers. These ionic liquids, besides providing ionic charges for conduction, these reduce the degree of crystallinity of polymer matrix. Ionogels can be obtained by dispersing ionic liquid or ionic liquid salt solution in polymer matrices using high molecular weight polymers like polyethylene oxide, PVDF, HFP, etc. The ionic conductivity of these polymer electrolytes is very low. Therefore, for their application in rechargeable batteries, different approaches have been adopted to enhance their conductivity. For example, using high molecular weight polymers, using nanofillers, or using plasticizers. Organic ionic liquids have emerged novel class of plasticizers which, besides enhancing the conductivity of polymer matrices suitable for fabricating lithium batteries, they offer the safety consideration. It may be recalled here that number of companies have recalled lithium batteries which were at the risk of explosion due to safety issues. Even Dreamliner 787 was grounded, which was due to the problem in the lithium battery used in that. Ionogel polymer electrolytes can be synthesized by conventional solution cost technique, and polymeric membranes can be obtained in desired shape. The cathode can be synthesized by dissolving the active cathode material in binder PBDF HFP, solvent NMP, and electron conducting agents like carbon, and then these can be coated on aluminum current collector in desired shape. Here some of the cathode materials which have been coated on aluminum current collector. Mesh type aluminum sheet has also been used so that coating can be done on both sides, and bipolar cell with high energy and power density can be prepared. On copper foil, lithium or carbonious anode material is also coated. Ionic transference number is one of the key parameters for determining the ionic transference number of the Ionogel electrolytes. The electrolytes which are used in lithium batteries, these should be perfect ionic conductor and electronic conductivity should be very low. Here it can be seen that the transference number is about 0.99, indicating that 99% of the ionic conductivity is contributed by the ions. One of the important parameters for electrolytes is their lithium cationic transport number. In this case, using combined acid-acid technique, the lithium cationic transport number is about 0.41, indicating that 41% of conductivity is contributed by lithium ions. Here are some of the results of the lithium cells fabricated using optimized electrolytes based on PBDF HFP and salt LiTFSI. It can be seen that the electrochemical window is around 4.78 volt, which is wide. CB indicates that the oxidation reduction potentials indicate the intercalation and deintercalation of ions. For optimized electrolyte and LFP cathode, the discharge capacity obtained is more than 140 milliampere hour per gram. Also, high rate discharge capacity is high. Another class of ionogels which are obtained by entrapping ionic liquid or ionic liquid salt solution in porous matrices is synthesized. In such systems, ionic liquid or ionic liquid salt solution, besides going into the pores, it also goes into the interparticle spaces, and there are abundant channels for conduction, and therefore its conductivity is liquid like. At the same time, mechanical support is also offered. Some of the results on MCM41 matrix based ionogels in which physical imbibition process was used and the resulting ionogen electrolytes were having very high ionic conductivity. One of the important properties of such ionogel electrolytes is they do not suffer from the effect of this dendrite formation or dendrite growth when lithium is used as anode material. Further, for such ionogel electrolytes, high discharge capacity is very high, and therefore these, besides suppressing the dendrite growth, have very high discharge capacity. At last, ionogel electrolytes are suitable candidates for realizing ionogel electrolytes based on polymer system, as well as these are realized by dispersing ionic liquid and ionic liquid salt solution in porous matrices. Thus, these ionogel electrolytes are a very good system for developing or fabricating efficient lithium batteries having high energy and power density. Thank you.